A very good evening to all of you. I, Riddhi Jain from Atal Innovation Mission Niti Aayog, welcome you all in today's Knowledge Hub session. Today, we are hosting fourth episode of our season 3. In this session, we are diving into a powerful topic, that is, AI is not just the future, it's a tool we can use today to solve the real world problems. Artificial intelligence is no longer limited to research labs or tech giants. It's shaping everything from healthcare to education, agriculture, and governance. Today, we'll explore how AI is being applied in practical, impactful ways across sectors. And to discuss this, we are thrilled to have with us Sri Rohan Malik, Senior Consultant at Dell Technologies, who brings deep insights into how AI is transforming industries right now. So, over to you, Rohanji.
Thank you, Riddhi. Hey, hello everyone. So as Riddhi stated, today we will be deep diving into how artificial intelligence, while it is being talked about that it is gonna go ahead and shape our future. Uh, However, there is a kind of lesson in there that we have, which is that Rome was not built in a day. While it is being said that there will be a day when AI will be used for all the tasks that we have been doing today, be it software engineering, be it uh, industrial expertise, be it agriculture, be it healthcare. But the fact remains that we have this technology today available with us, which is making its path forward in all these spheres. And today that's what we are going to go ahead and talk about. So the way we will structure today's conversation is one is that I understand that we will not be able to have a conversation with you guys because out of the sheer count that we have present here. So in case you have any questions, please feel free to go ahead and ping them in the chat, and we will ensure that we will go ahead and answer that either in the session itself or maybe we'll reach out through the chat. So with that, I will get started. The first thing that we will cover is artificial intelligence, the word itself, because to use anything, to use any tech that we have, it has to be understood first. Only then we can go ahead and put it to its best use. So artificial intelligence, as name says, intelligence, that is something we are going to discuss as the very first topic that we have, how it has evolved, how we humans perceive and understand intelligence. And then what is artificial intelligence, how it has evolved over, by taking an inspiration from human intelligence, what has been its journey, where it is today, and then we will deep dive into how it can impact the way you are learning today, or maybe the next impact will be the way you are planning your careers, and finally how it can go and solve the bigger aspects of global problems as well as social concerns that we have in society. So with that, let me move on to the first topic out of the four key topics that I've laid out. What is intelligence? Now, typically, if we ask you guys as students, you will usually relate intelligence to grades, that how much good or best of the marks somebody's achieving in their academics. Now that's one part of intelligence, that is for sure intelligence, but that cannot be stated that that's the only sort of intelligence that we as human go ahead and exhibit. That's academic excellence, no doubt about it. But there are other aspects of intelligence. So broadly, if we see, there are three, four key values that go ahead and define intelligence. One is that we go ahead and observe and learn from our surroundings. Second is, basis those observations and learnings, we can go ahead and reason with the environment that we are observing around us. We can use it to go ahead and solve problems, make our way out through things where we are stuck in, and then we adapt to the situations. Now, if you go ahead and analyze all those things, you will realize that yes, intelligence seems to be that it's not just related to studies. Someone can be a brilliant artist. So there the intelligence is artistic. Somebody can be very, very good at logic and analytical abilities. That too is intelligence. Somebody can be very good with linguistics. That they are very good in communication. So that's communication intelligence. So that ways we will see that all of us are gifted in some way or other with one sort of intelligence, which kind of is a bit better than other aspects of intelligence. So intelligence in its overall aspect, if you see, it is a very expandable asset. Neuroplasticity is the word that we go ahead and use for it. That just like any muscle, if you go ahead and exercise your brain muscles to go ahead and think about it, to get deep into it, you will get better at it. And that's how it works. So with that, we'll firstly go ahead and usually see how we go ahead and perceive intelligence in humans. So our brain, if you see that the first thing it does is it perceives, it absorbs, it sees, it listens, it feels, and it gathers the information that we have from the world. That's why we are in school. We are reading books, we are speaking to our teachers, to our mentors, to go and learn to the max that we can. Basis that, we go ahead and reason around it. We try to go ahead and find out patterns. We learn about gravity, and then we can go ahead and comprehend that why things go ahead and fall, why they move towards the earth, or why they move towards the bigger objects, because weight is the phenomenon behind it. So things like that. You understand the concept, then you try to go ahead and reason things that are happening around us because of that. And then you get into problem solving, that whatever is happening around you, say there is a task that you have to do. How can you go ahead and use the things that you have learned, the reasoning that you have attained over that? How can you go ahead and use it to solve it? And then once you have figured out how you need to go ahead and solve it, how you need to go ahead and convert a input into a output, you go ahead and act on it. Now, once you act on it, there will still be few things that you will end up missing. And those are the things that you will go ahead and learn and then adapt your your perception, your learning, as well as problem solving. We'll try to go ahead and gauge into it, that what kind of intelligence flow it is, through an example. We all have learned cycling as kids, right? So at that time, things which are involved in cycling, we actually did not understood those, right? We did not understand what is mechanics and the gyroscopic forces that are involved around cycling. That when it's in motion, it will be stable. When you have halted, you have to keep your feet down to go ahead and make it stable. We never learned that. No, nobody taught us that. Our first learning was observation or imitation. We were seeing our elder brothers, our friends, our fathers go ahead and ride these bicycles. We just observed them, that they are pressing the pedal, they are turning the handles, they are pressing the brake when they go ahead and want to stop it, and things like that. So that was observation. That also came along with when somebody is teaching you how to go ahead and ride a bicycle. They will go ahead and typically tell you that you need to go ahead and paddle, you need to steer with the handle, these are the brakes, these are the bells that you need to go ahead and ring when somebody is in the path, or things like that. So what you have done is you have learned a few facts from folks who have been doing it, and you have observed as well. Then you try to go and imitate that. You get on the bicycle, you start paddling. You still do not understand, how it is working. But as you have observed and you have listened to your, mentors or elder brothers, you are trying to go ahead and do that. Now, when you go ahead and try to do that, that is when you realize a few basic things in there, that paddling means that I need to go and press the pedal down from one feet first and then with the second. This is something that you are learning as you are acting on it, right? You understand that when I'm very fast, I cannot go ahead and suddenly turn the handle, or you can say the steering handle of the cycle, because I will fall. These are the things that you learn when you go ahead and actually do it. So that's acting and adapting to it. So this is how the intelligence can be defined, and we as humans are. This is not perhaps, in fact, the best asset that the Almighty has gifted to us. This is what makes it one of the superior species that we have on the earth. That we can go ahead and observe, we can learn out of it from the patterns, we can go ahead and act on it, and then we can adapt and make things better. So that cognitive ability that we have, that is what makes it stand apart from rest of the species. Now we will move further onto it. As I said, that intelligence is not just just about learning or reasoning or solving problems or adapting. it can be into different spheres. As I initially said, somebody can be very good with maths, so they are very, their logical intelligence is very high. Somebody can be very good with symbols. Now their pictorial reasoning will be very good. So that's a different kind of intelligence as compared to just a analytical or logical intelligence. Then somebody can be a very good artist, maybe in music or maybe in arts. That's artistic intelligence. Somebody can be very good in communication, in psychology. So they can be very good at, emotional quotient, or you can say communication intelligence as well. So there are flavors of smarts, and you cannot go ahead and rate one over the other. Every kind of intelligence that we have of intelligence in between humans. Now, with that, when we go and try to define this word of human intelligence, we understand that it's a very broad word. It can be used for logic, it can be used for understanding, for learning, for creativity, for very critical thinking, for research, for reasoning, for abstraction. And there can be a lot of aspects to intelligence. So it's a very broad term, and we really can't say that if somebody is good with maths, he's that's the only factor uh, implementing on the intelligence part of us as humans. So that's how we as humans go ahead and perceive intelligence. Now, of course, as humans, the way we have evolved is that whatever has been our most formidable asset, we have tried to go ahead and harness uh, it to its best of its abilities. We started initially, we were hunter gatherers, so we had good cognitive abilities, so we were able to go ahead and define kind of uh, we could go ahead and lay out safe terms for ourselves. We could build houses, we could build places where we can go ahead and be safe from forces of nature, from wild animals and things like that. Then we evolved into agriculture. We understood that we can go ahead and grow our own food. There we excelled by firstly doing it ourselves, and then we excelled into machinery by making it easier for us. We could grow at scale. Then we went into you know uh, seeds which are genetically modified and things like that. Then the industrial revolution happened. There too, we understood that we can go ahead and do things much faster if we go ahead and curate machines for ourselves. We understood mechanics, we understood the thermodynamics, and then we created machines. So whatever we could do in an human capacity through our cognitive ability, we were able to go ahead and enhance it. So that has been the human journey. Firstly, the agriculture revolution, we kind of harnessed it to its best, and now we are perhaps at the pinnacle of it. Same thing for industrial revolution. In industries as well, we are at the surge where we are creating industries on a flyby. Now the time is that the cognitive ability of ours, which is intelligence. Now we know that most of the things that we do today, be it, we are designing a software to perform any task, we are designing machines, we are designing houses, we are, manufacturing in industries, we are doing agriculture. In all those aspects, we go ahead and use our minds, right? So that becomes that our intelligence is our most formidable asset as of right now. So that is what we need to go ahead and harness. Now, are there any constraints on that? That is something that we will go ahead and discuss on the next slide. And the next slide is about when we talk about this intelligence that we as humans have, is there a way that we can go ahead and create it? And that is what artificial intelligence is. As the word says, artificial. It's not organic. It's not something that is designed by nature. It is something we as humans are designing. Earlier we have been designing machines, and now we are at a stage where we are at the onstop of creating intelligence artificially. Okay, so with that, I will move on to the next screen. So next screen is as you would be seeing right now, it is more to do
Uh,
with.
Rohanji, sorry to interrupt you, but the screen is not visible.
Okay, let me recheck.
Specifically.
Okay, great. Great. So guys, this is more to do with how a human gains intelligence. As we discussed when we were cycling, or we were trying to learning the cycling aspect of it. That firstly we observe, then we imitate, then we go ahead and detect patterns out of it. We see that when we pedal, we move forward. We are told or we observe that when we move the handle, it goes sideways, left or right. When we brake, it stops and things like that. So we are detecting patterns in there. We are observing people when they are cycling, and then we go ahead and analyze it, that these are the things that I need to do when I cycle. And then of course we draw some logical inference out of it, and that's a learning loop. Slowly and steadily we become very good at cycling. So this is something that is a learning loop of intelligence for humans. And it's not just for cycling, it's for everything. Let's take an example of chess, where which is perhaps considered to be the most brainy, or you can say a display of the best of cognitive abilities. There too you do the same. You observe, you go and see people playing, you understand what are the rules in there, or maybe you are told the rules. Then you go and detect patterns, that how different people are playing. You go and see them playing, or maybe you play with someone. Then you analyze why they would have moved this way or why they would not have moved this way. Then you draw inferences out of it, and that becomes a learning loop. So every time you play, you learn something new. Every time you play, you learn something new. You keep repeating this loop and you become a very good player. What you have done, you have used neuroplasticity to go ahead and increase your intelligence. Now what we need to do is we need to go ahead and try to go ahead and see if we can go ahead and make computers gain intelligence. And can they go ahead and do it? Let's go ahead and see if that concept can work for them. So conceptually, how machine gain intelligence, or something that we also coin as machine learning, they also observe. How can they observe? Through data. We have lots of data thanks to the explosion of computing that has happened in last 30 years. We have data, we have logs, we have monitoring information for almost everything, for every digital footprint that each one of us have in our spheres. And to add to that, the way the world is actually operating through its financial industries and manufacturing segments. There too the data available is huge. So observation comes through that data. Post that, like, we detect patterns when we try to learn. We can go ahead and program machines in such a way that they can also learn patterns into it. I will try to explain that better as we move on to the next screens. But yeah, that thing is that through statistics, which is maths, we can go ahead, machine can be programmed to go ahead and detect patterns in very complex data sets as well. And then it can go ahead and analyze those basis some very strong algorithms which have evolved over decades, over last 44 or 5 decades that we have. So with that, this learning loop completes. They observe just like us, they deduce patterns just like us, although we are designing it to go ahead and deduce those patterns. It analyzes and draws logical inference just like us using those algorithms. Again, we are the one who designed those. Then it tries to execute it. Again, it becomes a learning loop. So they can also go ahead and become the same chess players that we are. I will touch upon chess a lot here because uh, that has been a quite a basic principle for the evolution of intelligence as it has happened for last 3 or 4 decades. So in chess, data influxes that firstly you go ahead and provide rules, to your computing system, that these are the different units that go ahead and play in chess, and the pawn can move like this, knight can move like this, bishop can move like this, and things like that. Those are rules, or you can say basic data set. Then you can go ahead and provide it maybe recordings of a number of very good plays that which have been recorded in between best of the players of the world. So And then you can go ahead and program it through languages like Python to go ahead and observe that how different players are moving their pawns or bishops or queens or kings and things like that. And then analyze that, who has higher propensity or probability of winning. And in this loop, the machine has learned to go ahead and play chess just like a human has been doing for maybe centuries. So that is the base of how we are trying to go ahead and make machines think, or at least depict thinking like humans do. Okay, now we will move on to a very fundamental debate that usually happens, that what is difference between programming and this artificial intelligence. So I will try to make it very simple for you. Programming is also a kind of intelligence. However, we cannot go ahead and segregate that as a thinking intelligence, but it still depicts a kind of intelligence that humans have. However, the main difference between what we call as programming and machine learning or machine intelligence is that programming is very rule based, where we as humans go ahead and define some rules in our programs and or maybe some flowcharts, and basis that the decision making happens. On that program, a computing system does not take decision on its own. The second part that we have is machine learning, or you can say machine intelligence. Now, there, the ability of the computers to go ahead and learn without being explicitly programmed with rules. That is what machine learning is. The top aspect that I explained, which explains that how machines can gain intelligence, that is a typical example of machine learning. We did not provide any rules to machines by saying that when somebody moves this way on chessboard, this should be your move. That is something that machine had to go through by observing a large number of games or recordings of those, and then decide that what is the move it should make so that the winning probability is highest. So that's what machine learning is. Now we will move on to that. Can we compare this human intelligence and artificial intelligence? Yes, in a way we can. When we go ahead and talk about human intelligence, there are few humane things in there which kind of constrain us. And when I say humane things, they are like there is a limit of our memory of or what we can go ahead and retain. Like you and I may be able to retain a usual calculation table of maybe say up to 20 usually. Maybe if some guys are good, they can retain it for 100. But if you ask us to go ahead and retain a table for say 672, we will not be able to, because that's the constraint of memory size that we have. When we compare that to computing machines, that is not there. It can go ahead and retain in memory almost infinite count of facts that are required to be retained. At the same time, if we go ahead and talk about computational ability, if somebody suddenly ask us that go ahead and divide 67829 divided by 374, we will take some time. Computers will be much faster on that, right? Same on the speed as well, and same on the simulation. So if two people are playing chess, usually we say that the person who can go ahead and think of a lot many moves ahead of the other person, he is the one who wins. He or she is the one. Now there, the simulation part of it is has a limit. I or you can go ahead and only think about maybe 50 moves or 100 moves that can happen in chess in as the game progresses, and that is very dynamic as well, so that requires a lot of computation too. So there too, our simulation ability is a bit limited as compared to computers when they exhibit artificial intelligence. However, at the same time, there are few aspects of artificial intelligence which are very unique to human intelligence, like what artificial intelligence misses. One is true creativity and innovation. This is a feat that only a human mind can go ahead and achieve as of today. This means that while artificial intelligence can create things for you, while it can be creative, it still derives that from the historical learnings that it has from human history. It cannot, in principle, create a new thing through a creative way. That is something only a human can do, which is a very, very big feat when it comes to intelligence. The second thing is deep empathy and emotional quotient. Now, when you deal with people, when you engage with people, emotional quotient is a very, very important thing. Emotional intelligence, understanding others' feelings. Now, while a computer system or artificial intelligence might be able to go ahead and understand what you may be feeling, but that understanding is in terms of words. It actually does not feel it. It actually cannot feel if somebody is happy or anguish or maybe is disappointed. It can understand the word, but it cannot understand the feeling. That edge by humans is a huge aspect which kind of makes us better than AI when interacting with each other, when getting into a team spirit game, when working together on aspects. The third, which truly makes us human as better than usual logical intelligence, that is ethical judgment and wisdom. Now that is something which comes with social intelligence, which comes with how we have evolved over centuries and centuries of evolution of ours, how we have learned to go ahead and live together. Artificial intelligence, end of the day, will be logical. There are a few aspects that go beyond logic, which are things like social intelligence, social responsibilities, and things like that. A artificial intelligence system will understand that, but it will again will understand that as word. It will not understand that as emotion, the way it is required for us to go ahead and live in a social structure. Fourth thing, which is perhaps the most formidable asset that human intelligence has in terms of its superiority or artificial intelligence, that is consciousness and subjective experience. So that's actually understanding something for its aspect of it to humanity. Things like I will take a simple example: red color. Now, your computer system, artificial intelligence, will understand everything about red color, right? It's a sign of danger. It also, depicts a color which is there usually in roses and things like that. It also depicts a very strong emotion and things like that. But when it comes to color red, only a human can go ahead and see it and feel it. That kind of subjective assessment of your environment, not basis the facts or the words or linguistics, but basis what it is. That is something only a human can go ahead and do, and that what kind of separates it from artificial intelligence. I guess that's a lot into philosophy. So I'll move on to the next phase of it, and I will be a bit faster. That how this AI has evolved over years. In fact, I will just move on to the right side of it, and we'll just take a typical example of how it has worked. The very first evolution that happened was it started somewhere in 1950s, where Alan Turing, if you have heard the name of the scientist, he derived a word or wrote a paper which said, "Can machines think?" That can machines go and exhibit intelligence like us? And it was the starting of it somewhere in 1956. uh, John McCarthy, he is known as the father of artificial intelligence. He coined the word artificial intelligence, and then a lot of effort happened on that. And we started with the on the right side top, you something see something which says rule based deterministic automation. That is where we started. We, as I explained, we programmed rules, we put that into the system, and then it kind of exhibited sparks of human intelligence, or you can say try to mimic human intelligence in there. A typical example will be that if you're trying to go and uh, make a computing system learn chess, you go ahead and program it by telling it different moves that can be done with different kind of pawns, or maybe rooks or queens that it can do. And then you go ahead and define programmatically that if this is the move that the opponent is doing, this is the move you do. If this is the move he or she does, this is the move you do. So you are defining rules in there. You are not leaving anything on the computer system to go ahead and decide on. So that's very deterministic automation, that you go ahead and understand what can happen in the environment and then decide that and then go ahead and already define it. Then in somewhere in 80s we moved to the concept of machine intelligence, where we decided that now is the time that we need no longer to go ahead and program the system to go ahead and act through the rules, but we can rather program it to go ahead and observe the data and deduce rules on itself. So there, the example can be that we go ahead and provide lots of data to the system when it is trying to learn chess, different gameplays, their recordings, and it learns on its own that when one person is moving this way on chess, the other person makes this moves. So if you go ahead and give it thousands and lakhs of recordings, it will go ahead and learn a lot out of it and deduce a lot of logics at the back end. And then when we go ahead and play with that system, it will exhibit intelligence just like we do as humans. Right. So there as well, the concern was that it is only learning what is being taught through what has happened in the history. Can it go ahead and really decide on its own and dynamically the way the game is progressing? That is where the final phase came in, which we are in right now, which is reflective probabilistic intelligence, which is to do with that we go ahead and we do not go ahead and give it a kind of data just to go ahead and learn. We go ahead and give it a reason or a goal to go ahead and achieve. So you define that through programs, through usually through Python programming language is what we do. We go ahead and program it that uh, that the chess is a game. These are the rules that we have in there, and the goal is now, the definition of that goal is what sets different programs differently on this. That the goal is to go ahead and win the game. How do you win the game? By making sure that you go ahead and cut off the king of the opponent. Now that's one goal. Now that goal will have many sub goals, like your king should be alive. You should not go ahead and sacrifice your key players. Your key players are this. So you'll need to go ahead and define those, and the system understands that, and that is how it acts. Now the system is not merely dependent on its historical learning, but it understands why it needs to do something and then acts on it. Okay, so that's the era that we are in today, which we known as the generative era, where it can go ahead and dynamically decide, basis the environment it is in, basis the learnings it already has from us. Now, the only aspect that we need to remember here is one is how well we define goal for our program, or you can say for what we are trying to do, how holistically we define it. That is what sets us apart. The second thing is that how we go ahead and take care of the aspect that the machine is still learning from patterns, right? It is not that it is creating new ideas. We are just giving it different patterns that this is something, these are the rules, this is something that has been done. Now you derive out of it what could be a better way. Now that derivation will always depend on how well we go ahead and derive, or you can say define the goals that we are giving us. With that, owing to the paucity of time, I will move on to the main agenda that we have in today, that now that we have understand that how AI is working in today, how it can go ahead and help us not just shape up the future, but shape up our present so that future would look like how we imagine it to be. On the left side, the first page that you see on is for your learning. The first thing that it can do is, we all know that, there are availabilities of chat GPTs of the world, Gemini coming from Google, and from Anthropic, it's Cloudy, Grok. There are a lot of, models that are available, which are termed as artificial intelligence assistant as of today. Now, how they can be used very significantly by you guys is personalized tutoring, right? Today, when you go ahead and learn something, you have doubts. You have to go to your teachers to understand them. What you can do here is, and of course, when there are 30 or 40 folks in a class, they will go ahead and take their time to read it out and then clear their doubts. Here, what you can do is, say you are trying to understand Pythagoras theorem. You can just go ahead and ask your assistant Once again, here, what I stated earlier, goal is important. How you set up the goal. So how do you set up the goal for Pythagoras theorem? You state that I am a new learner into the field of mathematics. I have learned basic principles of mathematics till 8th standard. Now I am trying to learn Pythagoras theorem and other, trigonometry concepts. Can you please teach me right from basics of trigonometry and then go ahead and uh, scale it up to the Pythagoras theorem? If you go ahead and define a goal very well for the system, it will go ahead and give you a very good definition that how you can go ahead and which are the articles you can go through. Are the details. In case you have any doubts in there, if you do not understand anything, you can just go ahead and type in there. The only thing you need to remember is you give it a good goal, you give it a good context that it understands what you are trying to learn here, and it can be a very, very good personal tutor. You can learn anything in the world, right? You want to learn something which is not taught in, maybe in India as a country, which is being taught in, say, uh, in United States only. You want to learn quantum computing, you want to go ahead and excel on that. All of these things are available, and they are almost free of cost. Of course, at times there is a limit to what you can do in a day, but still, that comes, the limit is pretty extended and it can be used for individual purpose very well. Then it comes for language fluency. You can, using these chatbots, if you can use the word, or maybe these assistants that are available to us like GPTs and Geminis, we can go and learn any language, right? Usually when I was in school or college, when we had to learn language, we had to go through language schools. We want to learn German, French, or any other language. And there was a limit to, what were the availability of different languages. Now you can learn anything in here. It will correct your pronunciation. It will tell you what are the cultural differences those two countries or two states or two regions have. What do you need to take care of? So you can become, a kind of brilliant orator of French in 6 months. Then you can go ahead and research. Now, this this slide that I put together for you, I worked with Gemini Pro for about maybe 3 or 4 hours, and then I curated the content in such a way that it can be absorbed by anybody who is from 6th or 7th standard and even from 11th or 12th standard. So it can be very smart on research. It can give you what are the 50 top articles that you need to read through to understand AI or any of its aspect. That's what I was doing in there. So that's how it can help you today to go ahead and make your learnings best out of it. Then in your future development, like we engage into software development, we are using co-pilots who can go ahead and debug our code, can go ahead and make suggestions that this is not the most efficient one. You should go ahead and draft it this way and things like that. Healthcare and medicine, we know that through retinal scan today, AI cameras can go ahead and detect if some person has a probability of getting sugar, or maybe something that we call as sugar in India, but yeah, diabetic as a disease, or maybe kidney problems, right? Those things were almost impossible when doctors used to go and review them from their naked eyes. They had to put in a lot of effort, a lot of tests. Today that is available with the flick of a, you just click it and you have the results. Same in the finance and commerce, UPI segment, as we know. uh, Indian government has deployed AI reviews at the back end so that it can go and detect any frauds in there. So that's something that it is helping us today in industry, and I'm sure it will go ahead and help you guys as well in a much more evolved way. And then we have where we really need to go and use AI, fighting climate change, agriculture sustainment, disaster management, floods as they are happening. They are a hot topic in kind of wreaking havoc in Himachal Pradesh and Punjab. What we could have done, here it is. Google has a hydrologic model which can go ahead and basis the rains that have been happening in where these rivers originate, basis their levels. It can go ahead and tell us how much will be the rise in water levels in next 1, 2, or 7 days. It can go ahead and simulate the entire topography of the area and say that which are the areas which will be affected most by floods, which are the areas where we need to go ahead and have concrete banking, which are the areas which will survive this because they have a topography of a higher feet or things like that. So, I mean, these things are shaping our future. All we need to do is just get into it, get onto the AI assistants that you have, start asking questions, start asking goal-based questions, and you will evolve like anything. Okay, so with that and the paucity of time, I will have to end the session. I will open up and for any questions that we have here, please.
Thank you, Rohanji. That was an insightful session, and we did not want it to stop, but yeah, due to scarcity of time. Yeah, so we have received multiple questions, but we'll take few of them. So first is when implementing AI solutions in real world settings, what are some common architectural patterns or frameworks that you personally prefer to use?
Yeah, so that's a pretty good question, and we that's one of the challenge that we have in there. But yeah, I will try to make it very simple for you guys. When you try to use AI in anything, whatever you are trying to do, there are two aspects to it. One is understanding that AI itself, how does that work? The second aspect is understanding the problem or the person who is an expert in the sphere of that problem. What needs to happen is that this person or this team which understands the problem or the thing that we are trying to solve through AI, they and the AI team should work together in a very good sync. The problem is that these guys who have the problem or who are trying to solve something, they define, and then the AI team starts working on it blindly. Now, what happens there is, as I said, when we were defining goal for artificial intelligence, there the thing was that we define it well enough. Now, to define it well enough, what do we need? We need to understand the subject which we are trying to solve or the problem that we are trying to solve. So I think the best framework that we should get started right at the basic is that make a team which is very good in sync for the subject matter experts and the AI experts. They should be very respectful of the fact that both of them are very, very important ingredients of this solution. Alone, neither the subject team can solve it, nor the AI team can go and solve it. So the framework to start is define the problem very well, see what are the AI aspects that can be implemented in there. Both the teams discuss that, okay, this is the first aspect of the problem. In AI, have we solved it somewhere? Okay, we have solved it this way. What were the learnings from there? What were the gaps where we identified later when we actually deployed it? And that is when we identified. So these conversations should happen right at the start. And that is when you will scale up very fast and you will develop a solution which is actually good and actually is adds value to the system.
So, while we discuss about scaling up, what other biggest technical hurdles you see the person may encounter while deploying AI at scale, and how can they overcome that?
Yeah, so the biggest thing that usually we face when you try to scale up on AI is data. It's not that the data availability is not there. The problem is the structure in which that data is available is not very conducive for machine to understand. Right. So as I explained earlier, that when you are defining the goals, you define the goals very well. Then you need to go and provide data to the machine so that it can observe patterns. The problem is that data usually has a lot of noise, or you can say the structure of the data is not engineered very well. That's the reason a AI scientist or a data scientist alone cannot go and solve a problem. There are four people who go and solve a problem using AI. One is the person who is defining the problem or who's an expert in the problems. The second person is data engineer who actually collects the data and sets up the data in such a way that it can be ingested into the machine. The third person is who actually searches and defines the AI models that can be used. And the fourth person is someone that we call as machine learning engineer. He or she is responsible to go ahead and deploy these models so that they can really work fast. Usually you need decisions in split seconds. So they have to be deployed on a very powerful computing system in their most optimal way so that they can go and act. So these are the four things. And if you go and loosen up on any of these four, that becomes a challenge usually.
One question is, what role does synthetic data play in solving real world AI problems? especially when clean data is either scarce or sensitive?
Yeah, so that's I mean that's the problem that we usually have in almost all the spheres. One is, as I said, the data is not scarce. The problem is that data is not clean. Now, the good thing that is happening these days is the latest tech that is coming in, the latest algorithms. We have ways in which we can go ahead and synthesize data. Like we understand that, there can be, say, there are, say, 1 CR rows of data. Out of that 1 CR rows of data, we go ahead and, churn it and find out that only 10 lakh can be used. Only 10% is good enough. The thing is that earlier we were stuck with that 10 lakh, that if we go ahead and try to detect patterns in 10 lakh only, we will not get anything. Now the tech that we have is we can go ahead and synthesize that data to go ahead and convert that 10 lakh into a pattern which kind of maybe scaled up to 5 times of it. So that is something we can go ahead and use. The second aspect is, thanks to the generative AI, or you can say the prompt engineering techniques that we have, the LLM or MLLM models. There we can go and work with pretty less data as well, because there it's like speaking to a person, like we are talking. Earlier we had to program it using Python and other languages. Now it's like, I speak to you, I tell you, you go ahead and do this, and LLM, or you can say the machine, can go ahead and do that. So that prompt engineering has reduced dependency on data, but it has just reduced. It has not nullified it. So two ways. One is, whatever scarce data that you have, try to synthesize it to as much as you can. In case it's very sensitive, we should not do it. Just survive with that, scarce data that you have. Use prompt engineering principles over and above it, and try to go ahead and use it. At times, you will see that large language models will not give you that good of results because they are very generalized. In that case, you can go to SMLs, which are small language models, which are very specific in nature. But yeah, all these things that I'm speaking, you just go ahead and type in Gemini Pro, and it will give much better answers than me as well.
Then, about the sectors where data privacy is an issue, how to handle data privacy, model explainability, and compliance concerns when deploying AI in sectors like healthcare or finance.
Yeah, so that's where I was not planning to go and touch that concept, but I will have to. That's something that we call as guardrails. So guardrails, as we understand the word. Usually, when we are traveling on a road, on the sides there are rails deployed so that somebody may not topple over, especially over the mountains. This is the very same scenario. When you are traversing through a data which has PII, which we call as personal identify information. There, you have to be absolutely on your path. You cannot go and digress. So what guardrail management means is that you go ahead and define some principles for your models itself, so that in any circumstances it does not go ahead and digress from the main goal that you have. So you can go ahead and set principles like that. Out of the 80 fields that we have, these are the 40 fields which are very, very personal or PII information for the client. So the first thing that you need to do is you need to go ahead and see whether the client who is interacting with us right now is authorized and authenticated or not. There are software engineering principles which can go ahead and set up that for you. Once that is done, even beyond that, you can go ahead and define that for these 40 columns, no data should be shared while in conversation or while in reasoning with any of the chatbots or any of the reasoning models or any of the analysis that we are doing, because they are very, very specific to the customer and they may not want to go ahead and share it. At the back end, you can go ahead and churn it, but any insights coming out of it should not be shared. I mean, there are 4 or 5 guiding principles that we have for guardrail management, and they are available in plenty in white papers. They can be read, but yeah, there are ways in which we can go ahead and do it. There will be some kind of lack of reasoning models, or you can say reasoning performance, you will see because of that, but that's the cost of privacy that we have to take as of today.
We'll take one last question. How do you optimize AI models for latency and performance, especially for real-time applications?
Yeah, so I would say that's not an AI problem. I mean, as of today, that's a software engineering problem. The way you understand how in fact, there are two aspects to it. One is you have to understand how the computing and programming works. The secondly, you have to understand how the model works. Usually, what happens is that people are good with computing and programming understandings. When it comes to understanding of the model working, that's usually a black box. Folks like OpenAI or Gemini who actually define them, they do define the architecture, but they do not go and make it that open that you can go and understand what should be the most optimal way. So there you will need to go ahead and once again use the concept of, some of you guys must have heard it. It's called as AI ops, which is just like we had DevOps in software engineering and development, where we used to go ahead and deploy. AI ops means using AI to go ahead and check on these deployment decks, and it can go ahead and decide that what is the most optimal structure as well as the code that you have. So AI can solve it for itself as of today if we go ahead and use it well enough.
Thank you, Rohanji, for answering all these questions so patiently. And thank you for this truly insightful session that helped us see AI is not just a futuristic concept, but as a powerful tool that we can leverage to solve real world problems. And your perspectives have shown us how accessible, actionable, and impactable this AI can truly be when applied with purpose and responsibility. So, to our viewers, remember the true power of AI lies not in its complexity, but in how we choose to use it. And let's take what we have learned today and turn it into action using AI to drive innovation, meaningful challenges, and create a better future starting now. And with this, we will also request you to use these sessions, leverage this material that we are putting up on our YouTube channel for participating in currently running School Innovation Marathon. And thank you for joining us in today's Knowledge Hub session, Season 3, Episode 4. And stay tuned for our next session. Until then, happy tinkering. Thank you, Rohan.
Thank you.